So starting with the discussion of distance, time, and speed point graph exercise. As page 17 to page 36 was a weekly homework this week. It was supposed to be last week, right? So we already discussed 1 to 16, so we'll start with 17. In question 14, on page 17, question 14 is there. An astronaut is there on the moon, drops a feather from rest. So there's an astronaut and he dropped the feather from rest. So what is the starting speed? 0. The acceleration of a moon is 1.6. Means after every second, because acceleration means like rate of change in velocity, every second how much the speed changes. So after every second, like after 1 second, the speed will be 1.6. Then after 2 seconds, the speed will be 3.2. After 3 seconds, the speed will be 4.8. Means after every second, the speed will change by 1.6. That's acceleration. A feather falls for 4.5 seconds before it hits the ground. On the figure 1.1, draw a speed time graph. Look, when an object is falling without air resistance, it should have a constant acceleration, so there will be a straight line. But how we can complete this graph? So we can work out what will the speed of the feather when it hits the ground. So we have the formula that acceleration is change in velocity divided by time. The acceleration on the moon is 1.6. Final speed, we don't know. Initially, it was at rest. And we need the speed after 4.5. Like at what speed the feather hit the ground. So 4.5 is divided. Other side, it will be multiplied. So 1.6 into 4.5. This will give us a speed at which the feather will hit the ground. That is 7.2. So 7.2 is a speed. So 7.2 meter per second is the speed at which this feather will hit the ground. So when time is 4.5, like this, each box is representing 0.1. So 4.1, 2, 3, 4, and this one is 4.1, 2, 3, 4, and 5. So this is 4.5. The speed is 7.2. 10 boxes equals to 2. So each is representing 0.2. So this will be 6.2, 4, 6, 8, 7, and this will be 7.2. So 4.5. When the time is 4.5, the speed of the feather is 7.2. And because it's a falling object without air resistance, as moon does not have any atmosphere, so it must have a constant acceleration. So we draw a straight line from 0, 0 till the point where the speed is equals to 7.2 and the time is 4.5. Is it a clear discussion? Any doubt in this? Because the falling objects must have a constant acceleration, so there must be a straight line to represent a constant acceleration. And when the time is 4.5, the speed is 7.2. So 4.5 and 7.2, that's why we draw a straight line. Then determine the distance fallen by the feather. So how to determine the distance? For a distance, we have to use the area under the graph. Because the speed time graph, the distance travel is given by area under the graph. So we'll take the full area of this graph. What shape it is making? It is making a triangle. This whole part is a triangle. So we'll use a formula for the triangle, which is half base into height. So it will be half, the base is equals to 4.5 and the height is 7.2. So half 4.5 into 7.2, that makes 16.1. So the distance travel will be equals to 16.2. So the distance travel will be equal to 16.2 meter. Because the speed was in meter per second and time in second. So final answer of a distance will be in meter. If speed was in kilometer and time in kilometer per hour and the time is in hour, then the final answer will be in kilometers. On a figure 1.2, sketch a shape of a speed time graph for a same feather falling on earth. First, how it will be differ, like how it will differ. For example, if this was, as we draw, the acceleration of a moon is smaller, 1.6 only, and there's no atmosphere, so it will have a constant acceleration. But on Earth, what will happen? Earth is having strong gravity, so greater acceleration will be there on Earth. We don't have to sketch the graph of the moon here. I'm just drawing it to distinguish. So first it will have a constant acceleration, so it will be a straight line, but much steeper because the gravity of the Earth is stronger and acceleration due to gravity of the Earth is more, which is 9.8. And then what has happened? The Earth is having atmosphere, so air resistance reduces, like oppose the motion, reduce the acceleration, so the slopes start to decrease. And eventually what will happen? The feather will reach a constant velocity or a terminal velocity. So this should be there on Earth because Earth is having an atmosphere. So there will be an air resistance, but Moon does not have any atmosphere. And the gravity of the Moon is much weaker as compared to that of Earth. So that's why the initial slopes are different. For a Moon, a smaller gradient as compared to that of Earth, which is steeper. Explain the difference between speed and velocity. Include a word, vector, and scalar. So speed is a scalar quantity because there is no direction, where velocity is a vector quantity because there is a direction or it has direction. So scalar quantities are the ones which are not having a direction. Magnitude and unit is there, but no direction. Vectors have magnitude, unit, as well as direction. Figure 1.1 shows a speed time graph for a motion of a car. As you can see, this car initially it was having a constant acceleration. Then the acceleration, as the slope is decreasing, the acceleration is also decreasing because this part. And what might be the reason for a car to have a smaller acceleration, like acceleration decrease? Because as the speed of the car increases, the air resistance will also increase. So the force which opposes the motion is increasing. Say if the car is moving towards the right hand side, so as the speed of the car increases, the frictional force or the air resistance on the car increases. As a result, the resultant force on the car will decrease. Smaller resultant force, smaller acceleration. That's why the slope of the speed time graph is decreasing. The mass of the car is 1,200. Calculate for the first 20 seconds for the motion of the car, the distance traveled. So how we can find the distance traveled for what? First 20 seconds. So we check what shape it will make. It is making a triangle for first 20 seconds. And how to work out the distance travel? That is area under the graph. It will be half. The base is 20. And what about the height? Each box is representing, because 10 boxes equals to 5, so each is 0.5. So this is 10.5 or 11. This will be 12. This will be 13. So 13 is there. So we simplify, this will be 10 into 13, which will make 130. And the unit will be meter. So 130 meter is a distance traveled by this car in 20 seconds. Then acceleration of a car in first 20 seconds. So how to work out acceleration? Because for first 20 seconds, it is a straight line. So when it is a straight line, you have two possibilities for a speed time graph. If you need an acceleration, you can use a formula or you can use a gradient. Formula we use acceleration is v minus u over t. And for gradient, we will use a formula y2 minus y1 or x2 minus x1, like taking any 2 points. I prefer to use a formula, just substitute the values. So a equals v minus u over t. The final speed, it is 13. Initially start from rest, so 0, and the time interval is 20. So acceleration is 13 divided by 20, which is 0.65 meter per second. So this acceleration of the car, that is equals to 0.65 meter per second square. Resultant force. How to work out the resultant force? So use the formula F is equals to ma. The mass is 1200 and acceleration of the car is 0.65. So when you multiply 1200 with 0.65, it will give 780 newtons. So this will be 780. Describe the motion of the car from 25 to 40 seconds. So what is happening from 25 to 40 seconds? So like this is 25. So 25 to 40 seconds, the slope is decreasing. If the slope is decreasing, we can say the acceleration of a car is decreasing. And check the marks with reference to that. You will write like if it's of 1 mark, just it's enough. You mention that the acceleration is decreasing. If it's of 2 mark, you can mention acceleration is decreasing because the air resistance increase or the resultant force is decreasing. Question 16. At time t equals to 0, the resultant force act on the train and it start to accelerate. So this is a distance time graph. As the slope is increasing, shows means the slope is increasing. It means like rate of change of speed is increasing or accelerating. Use a figure, determine the average speed for 120 seconds. So how to work out average speed? Average speed is the total distance over total time. So 120, when time is 120, how much is the total distance travel? Each like 10 boxes equals to 1000, so each is 100. So 2 boxes below 5000, so it is 4800. The average speed is the total distance, which is 4800 divided by total time 120. So this will give us 40 meter per second. That's the average speed. The speed of a train at 100 seconds. So we need the speed of a train at 100 seconds. It means this part. So this particular point, we need the speed. Or this section, we need a speed. So what we can do to work out the speed at a particular point, we find the gradient of that region. So we can find the gradient of this straight line. This whole part, it's a straight line, so we can find the gradient of this part until the line is straight. And use the formula y2 minus y1 over x2 minus x1. So the first point on y-axis, on x-axis, that is x1. So this one is x1. The second point on x-axis is x2. The first point on y-axis is y1. And y2. So this will be 10 boxes on x-axis, 10 boxes equals to 20. So each box is 2. So 62, 4 and 6. So this is 66. So x1 is 66. x2 is 120. y1, this is 1000. Because 10 boxes equals to 1000. So each is 100. So 1100, 12, 13, 14, 15, 1600. So this is 1600. That is y1. And y2, that is 4800. So we use a formula y2 minus y1 over x2 minus x1 to get the speed at 100, because speed at 100 seconds is same as in this whole region, as it's a straight line. So y2 is 4800, y1 is 1600, x2 is 120, and x1 is 66. So 3200 divided by 120 minus 66, which is equals to 54. And 3200 divided by 54, which is 59.25 meter per second. So we get the speed as 59.25 meter per second. For this question, like getting the speed, it will have a range of answer. There's no specific fixed answer. You will have a range of answer from like 50 to 60. Is it clear, this one? Any doubt in discussion? Okay. The next question. Describe how the acceleration of a train at 100 seconds differ from 20 seconds. Look, at 100 seconds, it was a straight line. Distance time graph, and it is a straight line. What it shows the constant, like we can say constant speed, because it's a straight line, so constant speed, or we can say there's no acceleration. And this part at 20 seconds, as the slope is increasing, as the slope was increasing, so it was accelerating because the speed was changing at a different rate. So this was accelerating. So at 20 seconds, we can say the train was accelerating, but at 100 seconds, the train was not accelerating. It was moving with a constant speed. So how the two accelerations are differ from each other? At 20 seconds, the train was accelerating or changing the speed, but at 100 seconds, acceleration was 0 because it moves at a constant speed. In question 17, acceleration of a car accelerates from a rest. So as you can see, when you are explaining a motion of a car, you will find such graph is very common. In the beginning, the car is having a constant acceleration, then acceleration decrease, and until it has a constant speed. So what we can say about the resultant force when it was a constant acceleration, we can say the acceleration was like resultant force was constant here. Then the slope is decreasing. We can say the resultant force is decreasing, and eventually it is a horizontal line, so there is no acceleration, or we can say resultant force is 0. So here the acceleration was constant. Here the acceleration was decreasing, and at this point the acceleration is 0. The mass of a car is 2,300 kg. For a time between 0 to 5, determine the acceleration. 0 to 5, it's a straight line. So when it's a straight line, it's up to you. You can use a gradient, or you can also use the formula. So I prefer to use a formula, so I'll use a formula here that when it starts, the starting speed was 0. At 5 seconds, the speed was 15, and the time interval is equals to 5. So if you want to calculate the acceleration, it's the change in velocity divided by time. So it is 15 minus 0 divided by 5, which is equals to 15 divided by 5, or we can say 3 meter per second square. So acceleration of the car was 3 meter per second square. Moving on to the next question, question 18. A train of mass 1.8 exponent 5 kilogram. At time t is equals to 0, the train begins to accelerate, reaches a speed of 20 meter per second at 15 seconds, and then train continue at speed for of 20 meter per second for 10 seconds. Then from 25 seconds, the driver applies the brake and the train decelerates. We have to complete a figure 2.1 by drawing a line represent a motion of a train from 15 to 25 seconds. So from 15 to, because for first it was accelerating for first 15 seconds. From 0 to 15 it was accelerating, but from 15 it for 10 seconds, like 15 to 25, it was not accelerating. It was moving at a constant speed. So how we can show this? 1, 2, 3, 4, 5. So this is representing 15 and this is representing 25. So from 25 to 15, it is a straight line. So use a ruler. You don't have to do any calculation. Use your scale or a ruler and draw continuous line, a straight line from 15 to 25 or 25 to 15 second. And then from 0 to 15 second, the 0 to 15 second, the train was accelerating. How we represent the acceleration of a train? So we have to just join this, but to show that the slope is increasing, not a straight line. You don't have to draw a straight line. You have to draw curve, which shows like a distance time graph. When we show a curve, it means the speed is increasing or it is accelerating. The slope here does not matter. It's just a continuation. You just have to show. It's of only 1 mark, so no calculation, just a sketch. Like it should look that the acceleration is increased, like the speed is increasing and it is accelerating. The curvature is not important, like how much curve you make, that is not important. Important is like it should appear that the slope is increased. In question 19, a cyclist start at A, follows the part A, B, C, D, E, B, like means he returned. Speed time graph is shown. Calculate a distance from A to B. How to calculate a distance from A to B? So A to B, it is making a triangle. So how to find the distance A to B? Half base into height. So it will be half, the base is 20 and the height is 6. So it will be 60 meter. So from A to B, that is equals to 60. Circumference of the path. Circumference means, as you can see from, they give you the hint, like from, because circumference means moving the distance travel on a circular path. So from B, then C, then D, then E, and then back to B. So means we need the distance of this part only, like area of this part for a circumference. Not from starting A, only from B to B. So what shape it is making? It is making a rectangle. So we'll use a formula length into width. So starting from 20 and ending at 72. So this is equals to 52, the total length. And starting from 0 and ending at 6. So this is equals to 6. So it will be 6 multiplied by 52. How we understand it is from B to B, because in the question they mentioned circumference. Circumference means it should be a close loop should be there. Like you should return back to the same point. If, for example, you are at position A, when you move around and you return back to position A again, the distance you cover is called a circumference. Means we return back to the same point, then we call that distance cover is a circumference. So when you check the graph, which point are repeated again? So this is B and this is B. So means we have to calculate a distance when we start from B and we return back to B. That's why we are only calculating from B to B. Is it clear, this one? Then in question 20, a bus travel from one bus stop to another to the next. The journey has 3 distinct parts: a uniform acceleration for 8 seconds, then a uniform speed for 12 seconds, and then non-uniform. On a figure, complete the graph. First 2 parts. So how we can complete the first 2 part? Uniform speed time graph, uniform acceleration for first 8 seconds. So this one is 10 boxes equals to 5, so each is 0.5. This is 9 and this one is 8. And because then it move at a constant speed, so first part, a uniform or a constant acceleration. So we draw a straight line. Then a uniform speed or a constant speed. So how we represent? So this will be a uniform or a constant speed. Then calculate the acceleration of the bus first 4 seconds. So how we can calculate the acceleration? This is 4 seconds. So when it is 4 seconds, what is the speed? That is 6. So final speed is 6. Initial speed is 0 and the time interval is 4. So we use a formula. Acceleration is change in velocity divided by time. So 6 minus 0 and divided by 4. So acceleration is equals to 6 divided by 4, which is 1.5 meter per second. That's the acceleration of the train. Estimate the distance 20 to 126, 20 to 25. So you just have to do estimation here, like find the area under the graph, and your estimated value should be less than this because it is not making a perfect triangle. So if you use half base into height, the base is equals to 5 and height is how much? That is 12. So this is 11, 12. So half base into height, when we simplify, 6 multiplied by 5, 30. 30 meter, if it, this is half base into height, so 30 meter, if it is exact. But because it is not making a perfect triangle, so any value less than 30 is acceptable. Like you just have to estimate. When you calculate, you got 30, but because this is not making a perfect triangle, it is like actual triangle should be like this, but this triangle is having a small area. So it means it should be less than 30. If it was a perfect triangle, it should be 30. But it's a smaller, so you can write any value like 27, 28, 29, 26. Is it clear, this one? Why we did not write 30, we'll write less than 30 because it's not making a perfect triangle. Then a car starts from a rest and complete one lap in 10 seconds. Describe the motion of the car from 3 seconds to, it's a speed time graph, so 3 seconds to 10 seconds. It means a constant speed. There is no change in speed. A constant speed is there for this car. On a figure, 1 point, calculate the circumference. Look, in this case, this is a graph given for a one complete lap. So one complete lap, that total distance will be equal to the circumference. Now we have to find the area of the whole graph. Because they mention here, this is a car is there, it started from rest and complete one lap. And this is the motion of the graph is there representing the motion of the car, the speed time graph. So we find the total area, first triangle and then rectangle. So area of the triangle will be half, base is 3 and height is 25. So, and this will be length starting from 3 and ending at so 7, and the height is equals to 25. So this will be half base into height, so half 3 into 25, like 75 divided by 2, which is 37.5. And this will be 7 times 25, which is equals to 175. And 175 plus 37.5 makes 212.5. So 212.5. And because the speed is in centimeter per second and time in second, so this will be centimeters, not meter, depending on the unit of the speed. So total area under this graph, which is 212.5, and the unit will be centimeter. Then calculate, so this was 212.5 centimeter. Then increase in speed per second from 0 to 3 seconds means acceleration. So for first 3 seconds, what is the acceleration? Because it's a straight line. So we'll again use a formula. Acceleration is change in velocities. Final is 25. Initial is 0. So 25 minus 0 divided by time is equals to 3. So it will be 25 divided by 3, which is equals to 8.3. 33 meter per second square. That's the acceleration of the car for first 3 seconds. 8.33 meter per second square. Figure 1.1 shows a speed time graph for two falling objects. One is a rubber ball, another one is a plastic. Both are dropped from the same height. Use the graph, find the average acceleration of a rubber ball for first 3 seconds. So this is a rubber ball, the graph for a rubber ball. We need an acceleration, the change in velocity divided by time. So this is in between. Each 10 boxes equals to 1. So each is 10 boxes equals to 10. So each box is 1. So this is 21, 2, 3, 4, 5, 6, 7, 8. So this is 28.5. And the time, the initial speed is 0. So it will be V minus U over T. Which is 28.5 minus 0 divided by 3. So 28.5 divided by 3 equals to 9.5. So acceleration equals to 9.5 meter per second square for a rubber ball. Then distance fallen in 3 seconds. So how we can work out the distance travel? We just use the area of the graph or area under the graph for a rubber ball only. So what shape it is making? It is making a triangle. So we'll use a formula half. The base is 3 and the height is 28.5. So it will be 28.5 times 3 divided by 2. That is 42.75. So the distance traveled will be equal to 42.75 and the unit will be meter because speed is given in meter per second. Another question, the graph shows the speed of a car changes as it passes through a small town. Like at point B, it enters the town, and at point C, describe what happened to the speed of a car from A to B. So y-axis is a speed. So you can clearly see that the speed of a car decreases from A to B. Then from B to C, no change. It is constant. And from C to D, it increases. The next part, calculate the distance between the start of the town and end of the town. So distance traveled between start and end of a town. So you have to find area under the graph. This is a point where the town started, and this is a point where the town ends. So 10 boxes equals to 10, each is 1. So this one is 18, this one is 42. So from 18 to 42, that is equals to 24. So length is because 42 minus 18, that will be equals to 24. So the length is 24. And height is how much? This one, each 10 boxes equals to 5. So each is 0.5, 11, 12, and 13. So this is 30. So it will be 24 multiplied by 30, which is equals to 312. So the 312 meter is the distance traveled by this car. And acceleration from C to D. So how to work out acceleration from C to D? At point C, what was the speed of the car? It was 13. At point D, what is the speed of the car? If you check, you can find the gradient or you can also use a formula. So it is 31. So speed at this point is 31. But what about the time interval? For time interval, you have to check the x-axis. So this one is at 42 and this one is at 51, 2, 3, 4, 54. So 42 minus 50, so 12 seconds are there. because this one is at 42. This is 54. So time interval moving, it will be 12 seconds. So it will be 31 minus 13 divided by 12, which is equals to 1.5. So acceleration of this car is 1.5 meter per second square. How the graph shows acceleration and deceleration have the same numerical value. Look, if we say acceleration and deceleration are same, so simple idea is that they will have the same gradient or angle. If two lines have the same gradient or angle, it means they will have the same acceleration for a speed distance time graph. In question 24, a girl's ride on her bicycle. As you can see, describe the motion. It's a distance time graph. Distance time graph. The slope represents speed. So from A to B, what happened? The speed increases because the slope is increasing. B to C, the speed is constant because the slope is constant. And from C to D, the speed is decreasing because the slope is decreasing. Then average speed and the maximum speed. To calculate her average speed, we need a total distance over total time. So total distance, she covered 400 and the total time is 60. So 400 divided by 60, which is 6.6. So 400 total distance divided by time 60, which is 6.67 meter per second. But we need our maximum speed. That's for average. But how to get the maximum speed? For maximum speed, find a region where the slope is maximum. Slope is maximum between B and C. So we just have to find the speed from B to C. So how much distance travel from B to C? At point B, it reaches point C. So when it was at point B, what was the distance? This is equals 10 boxes equals to 100. So each is 10. So this one is 70. And this one is 310, 20, 30, 40, 50. So 350. So how much distance it covered? The distance covered is 280 from B to C. And what about the time interval? So this was 15 seconds. You can also find the gradient. This one is 45. So the time interval is equals to 30. So it will be 280 divided by 30. So we simplify. So 28 divided by 3, which is equals to 9.33 meter per second. That's the average, that's a maximum speed. Is it clear, this one? Discussion?